purpose of this video is to get you caught up on things that you may have missed. And this part in the year, these are the things that I'm expecting you guys to be very familiar with and to know off the top of your head. So in case you missed that or you didn't catch it the first time we did it, I'm making a short video right now, and I'm going to go through all of the factual knowledge that you should know at this point. If you are watching this and you're feeling like that you missed a lot already, or you didn't catch it, or you haven't heard it yet, then definitely take notes on this video so that you have them in the future. Okay, so here we go. We're going to go through them one by one. So just some definitions here. So our one of our most basic definitions is just position, and position is simply where is something. It tells you where something is in relation to something else. For example, if we had a starting point of 0, and then each one of these boxes or lines on this graph is representing 1 meter, then we can say if the object is right here, then we can say its position is 1, 2, 3, 4 meters away. So that is a quick example of what position means. It is telling you where something is, and it is basically that simple. Some other things about position: it has some standard units and variable. The standard units that we use are meters. Occasionally we'll use centimeters, but the standard for most physics equations is going to be meters, and the variable that we typically use is going to be x. So when you see this in an equation, x is talking about position. So let's look at our velocity equation is x over t. So that means our velocity here is equal to the position divided by the time. So that is example of position and the variable that we are using here. Okay, displacement is often confused with position, but it relates to positions, specifically your final position and your initial position. So if our, let's look at our number line again. So if this is our number line, and each tick mark again is 1 meter, and 0 meters is exactly right here, then our final position minus our initial position is just ever so many meters divided by ever so many meters, and that will give us our displacement. So for example, if we had a final position of 1, 2, 3, 4, 5, if we had a final position of 5 and our initial position was 1, then our displacement here is just 5 minus 1, so our displacement is 4. Okay, that is displacement. It has the same units in meters because you're looking at distances, and our variable here is something you may not have seen before until you've come to physics, is this triangle. This triangle here is called delta, and that means the change in. The change in is always a final, the change is always a final minus an initial. Whether it's a velocity or a position or a time, it's always the last value minus the first value. So that is displacement. Speed. This is something you're very familiar with already. The idea of speed is just how far do you go in a certain amount of time. The formal definition is total distance divided by the total time. Our variable that we use is v for oftentimes velocity. But if it is a speed, then there is no direction. So an example of speed, not velocity, an example of speed would be 10 meters a second. So 10 meters per second. Or something you're more familiar with, miles per hour. Miles per hour. So it's 10 miles every hour. 10 miles per hour. That would be a speed. So again, the formula is just what's the total distance and what is the total time, divide the two. And then our units typically are going to be meters per second. So meters per second. We're dividing a distance in meters divided by time in seconds, so that gives us meters per second for our units. average velocity. Okay, this is similar to the speed that we just discussed, but it has a direction. And what we see down here is that average velocity, this little bar here in your math class, you may remember, that means average. So that is average. And we already know what delta x is. That's change in position. Delta t is just change in time. So if we look at the expanded equation, then we have this. X final minus x initial divided by t final minus t initial.